Avogadro's law. So I'll read off the problem, and then we'll tackle it just like the other ones. So it says, if we have 0.75 moles of helium gas, so that's my initial number of moles, so my n sub 1, it occupies a volume, so that amount is occupying a volume of 1.5 liters. It's now asking the question, if I put in 1.2 moles of helium instead, what would happen to that system? Would it expand or contract? Would it stay the same? So it's asking me to find, if I had 1.2 moles of helium, what is the volume? As long as P and T are constant, right? So we have Avogadro's law, and we see that it relates a condition 1 to condition 2. And again, I got to figure out, make sure I know if I have my unknowns and what I'm solving for, or sorry, if I have my knowns and what I'm solving for. I know V1, I know N1, I know N2. V2 is what I'm solving for. So that means I have 3 knowns, only 1 unknown I can solve. So again, let's arrange the equation so we have V2 by itself. I can multiply both sides by N2 to get V2 by itself. So it would look like V1 N2 all over N1 equals V2. So now I can just dump my numbers in, plug and chug. V1, my initial volume was 1.5 liters. My N2 is 1.2 moles. And under condition 1, I only had 0.75 moles. Moles and moles cancel. I'm left with units of liters, which is a unit from volume, so that makes sense. I do my math out to 2 significant figures, and I should get 2.4 liters. And that should make sense. I have a small amount of moles. It's only going to take a small amount of volume to contain it under a constant pressure and temperature. I put more moles in, volume gets bigger. It's basically described as happening in a balloon. You blow into a balloon, you're putting moles of gas in, it gets bigger. It's exactly what Avogadro's law describes. And so that's the first part.